This section deals with simplifying radicals. The term for radical of a particular type is a square root. So we're going to look at simplifying square roots. First of all, when is a square root not simplified? The first situation is if you have no factor that contains a perfect square, and I'll go over that in a moment. And also you cannot have a square root, I'll do the square root symbol, you cannot have a radical square root symbol in the denominator. If either or both of these are true, you must keep going simplifying radicals. First of all, let's look at what perfect squares are. These are numbers such that when you take the square root of it, let me do an example, and just do our integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you square 1, we have 1. If you square 2, you have 4. Square 9, 3, excuse me, 9 square 4, 16, 25, 5 squared, then 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. The second row, these are called perfect squares. If you take the square root of these numbers, you get an integer. So the square root of 1 is just 1. The square root of 4 is 2. The square root of 9 is 3, etc. The square root of 25 is 5. So if I ask you, why is the square root of 4 equal to 2? Well, the square root of anything has to be that number expression times itself 2 times to equal the value. So square root of 4 is just 2. The reason why 4 can be written as square root of 2 times square root of 2, maybe an easy way to see it, the square root of anything times the square root of that same thing is equal to that, in this case, number without the square root symbol. So if I say what the square root of 25 is, I don't want you actually, even though this is correct, to do square root of 5 times square root of 5, which is 5. I want you to recognize square root of 25 is a perfect square, and the answer is 5. So what's the square root of 98 times the square root of 98? Well, I wouldn't want you to multiply 98 by 98. You have some humongous number. Once again, the square root of anything times the square root of that same thing is that, in this case, number without the square root sign. So square root of 10.1 times square root of 10.1 is simply 10.1. Okay, let's talk about simplifying radicals of square roots that are not perfect squares. So 98, there is no integer times itself that equals 98. So 98 is not a perfect square. You want to think, what are the factors of 98? It's best if you can think of one that contains a perfect square. Well, this one's pretty easy because half of 98 is 49. Keep your root symbols. If 49 times 2 is 98, well then the square root of 49 times the square root of 2 is the square root of 98. Anytime you see a perfect square, you should take it. Just rewrite that number without the square root sign. So the square root of 49, although you could write square root of 7 times square root of 7, that would be long and not really useful. Square root of 49 you should be immediately be able to go and say a 7, bring down the radical 2, it's a multiplication in between, so the answer to that is 7 radical 2. Similar examples. Simplify square root of 27. There aren't many options here for the factors. The square root of 9 times square root of 3 is square root of 27. Square root of 9 is a perfect square, it's 3, so I bring down the 3, I bring down the square root of 3. Notice, this square root of 3, it's a prime number, so therefore, of course, it is no other factors than 1 and 3, and therefore that's as far as we can go. It's not a perfect square. Square root of 108, a little larger numbers. Well, I try to find the biggest perfect square that goes into the number. So I think of all the perfect squares, 1, 4, 9, 16, 25, etc. And I know 36. I'm going to do it another way. 36 times 3 is 108. The square root of 36 is 6, so 6 radical 3. However, you may want to consider, if you weren't as quick in doing that one, I'm going to do it again. Square root of 108. 108, half of 108 is 54, so 54 square root of 2. Let's erase this. Have some space over here. Square root of 54. Well, 54, if I break that down, there are quick ways to do it, but I'm the long way. Square root of 54 is 27 radical 2. So this is both of these are 54. I bring down the square root of 2 again. Equal to, well, square root of 27 is square root of 9 times square root of 3. And now notice this square root of 2 times square root of 2. Anytime if we have a square root times itself, then we get that number without the square root. So that's just going to be 2. We keep going. Running out of space, but we'll go up here. Square root of 9 is 3. So we have 3 square root of 3 times 2. And now 3 times 2 is 6. 6 radical 3. So you can see we get the same answer, but it's much easier if you find the biggest perfect square that goes into those numbers. So I think it's helpful if you write out those perfect squares and take half the number and try to find which one goes in. Some other examples. (12 square root of 48). So again, I'm going to try to find the biggest perfect square. Well, for me, half of 48 is 24. It's not a perfect square. I keep going to the next perfect square, which is 16. So I break down the 12. Square root of 48, therefore square root of 16 times square root of 3. I just go from north to south. Square root of 16 is 4. Multiply like numbers. 12 times 4, both numbers without roots. So that's 48 radical 3. Alternative, if you didn't recognize that 16 went to 48, so I'm going to do a longer method. Same problem, 12 square root of 48. You could divide 48, you can divide by 2 or 4. I'll go slower and divide by 2. It would be better to divide by 4 because square root of 4 is a perfect square. But if I did it by 2, square root of 48, we're going to have 2 and 24, both with roots. 12 can't combine with anything. Square root of 2 can't be simplified. But square root of 24, I could do 4 and 6, which would be preferable to me, but I'm going to just keep it in case those who divide by 2. Square root of 24 is factors of 2 and 12, so therefore square root of 24 can be written as square root of 2 times square root of 12. Bring everything down, but here I notice a square root repeats. I'm going to bring down the 12. But square root of 2 times square root of 2 is 2 without a root sign. I'm going to break down square root of 12 to be square root of 4 times square root of 3. So we have 12 times 2. I could do that as 24, but I'll wait for that. Bring down the square root of 4, which is 2. Bring down the square root of 3. Square root of 3 can't be broken down anymore, so that's going to stay a square root. I'm going to multiply these 3 numbers, all without radical signs. So 12 times 2 is 24, and 24 times 2 is 48. Notice we get the same answer as if we found the biggest perfect square, which was 16, and did it. Now we're going to get to some square roots in the bottom. If you recall, I said you cannot have a root simplified if there's a square root in the denominator. The process to get rid of this is called rationalizing the denominator. To get a square root out of the denominator, we know it's legal to multiply any number by 1 and not change its value. So what do I want to multiply this by the denominator to get rid of the square root of 2? Well, we know the square root of any number times the square root of that same number gets rid of the radical. So square root of 2 times square root of 2 is 2. But I just can't multiply a number, or divide a number in this case, by square root of 2 because I'm changing the value. So I can multiply by 1. So to make this fraction a value of 1, I'm going to put square root of 2 on top. Right? Because square root of 2 divided by 2 is 1, so I haven't changed the value. So now I multiply my numerator, so it's 8 radical 2. I got rid of the square root on the bottom, so it looks like we're done because square root of 2 can't be broken down further. But notice as with regular fractions, the numbers that are the same type, in this case without integrals, can be divided. So 8 divided by 2 is 4. So the final answer to this is 4 radical 2. Once again, what's the final answer? No radical in the denominator. We accomplished that. And a square root cannot be broken down further. Once again, the process to get rid of the radical in the denominator is called rationalizing the denominator. Similar problem. So think, what do we have to do? We have to get rid of that square root of 6 in the bottom. So whatever's in the bottom is the square root. You do that. You have to put it in the numerator as well. So we multiply both the numerator and the denominator by square root of 6. We get 5 square root of 6 on the top. We get 6 in the bottom. And this actually is simplified. 5, 6, the numbers without radicals have no common factors. Even though square root of 6 can be broken down to square root of 2 and square root of 3, neither of them are perfect squares. There's no other radical in the numerator to combine it with, so that step was unnecessary. Another example. Square root of 28 divided by square root of 8. So once again, we can multiply the number by 1, the square root of 8. A couple things we could do. I could try to break down the square root of 8, factor it out, but there's still going to be a radical in the bottom, so I'm just going to do the regular method, multiply the top and the bottom by square root of 8 over square root of 8. And if we do that, the numerator is going to be 28 square root of 8 over 8. This one is definitely not simplified for a couple of reasons. First of all, our fraction of 28 over 8 can be simplified. 4 divides both of those numbers, so if I did 28 divided by 4, I'm going to get 7. If I do 8 divided by 4, I get 2, right? So just check that. 28 over 8, I can take half of it. That's going to be 14. Half of it again is 7. That's equivalent divided by 4. Half of 8 is 4. Take half of 8 again, that's 2. So 7 halves is equivalent to 28 over 8. But that square root of 8, I'm going to just write it here. This whole thing is on the bottom. So the 2 is under the entire term at either one of these numbers. Well, the square root of 8 can be broken down. I'm going to do it over here. Square root of 8 can be square root of 4 times square root of 2. I'm going to keep the 2 in the denominator. Now, when I see a perfect square, I take it. So just writing in order, I'm going to keep that 7 on top. The square root of 4 is 2. The square root of 2 remains square root of 2, and the 2 in the bottom. Since it is all multiplication in between terms, I can cancel those 2's in the numerator and denominator, and the final answer is 7 square roots of 2. Okay, one other property that's legal to with radicals. Suppose you have a fraction, I'm going to use letters, where a and b are positive numbers. If you have the square root of the entire fraction, you can take that and write that as the square root of the numerator over the square root of the denominator. So this is the legal step. So in some problems when they go in evenly, and this is a really easy one, when you see 27 divided by 3, although you could write it as square root of 27 over the square root of 3, using the rule above, I would not recommend doing that. And the reason why, for this particular problem, we know that 3 goes into 27 9 times. So just do 27 divided by 3 is 9. We have to keep the radical because it's under radical sign. And then we take the square root of 9, and we get 3. So that was a nice, simple, easy one. Another one similar to that, square root of 16 divided by square root of 2. Although I could write as square root of 16 over square root of 2. Notice 2 goes into 16 8 times, so it's probably easier just to do that. And now using the old rules, break down square root of 8. Square root of 4 times square root of 2, which is 2 radical 2. That is the final answer for that. Okay, but let's get to ones which don't go in evenly. So here we have 27 over 2. Although square root of 13.5 would be correct, when they don't go in evenly, we don't want to divide it where there is a decimal answer. Only divide if it goes in evenly. So in this case, we do have to split it up. The square root of the numerator over the square root of the denominator. My first step, I'm going to multiply by square root of 2, because it's in the bottom. Square root of 2 to get rid of that square root of 2. So that's square root of 2. And I guess I'll make this, at this point, 54. 27 times 2 is 54. And I write it down here. So I have square root of 54 on top, and I noticed I wrote square root of 2 in the bottom, which should not be there. So let me just backtrack. Square root of 2 times square root of 2 is 2. Put that on top, so square root of 27 times square root of 2 is square root of 54, and we have the 2 in the denominator. Well, now we need the factors of 54. So you think, what times what equals 54? Well, 9 times 6 equals 54. Square root of 9 is 3. Times square root of 6 divided by 2. And this is simplified. 3 halves have no factors common, although square root of 6 can be broken down to be square root of 3 times square root of 2. There's no square root of 3 or square root of 2 in the bottom, so you can't cancel it off. There are no other square roots in the numerator, so therefore that was not a necessary step. A couple last things. When you multiply numbers, we're not distributing, you just multiply, so you combine like terms. So 2 times 3 is 6, so this is 6 square root of 6. Square root of 6 as the example above, although it can be written as square root of 2, square root of 3, nothing to combine it with. Suppose I gave you 2 times square root of 6 times 3, now let me throw in a square root of 12. Well, 2 times 3 is 6. 6 and 12. I could do the square root of 72. I'm going to put it down here. So 2 times 3 is 6. I'm done with those. Okay, so 2 times 3, make that 6, so these come here. So I could do 6 times 12 is 72, and write square root of 72, but I notice square root of 6, I'm going to keep that as 12 can be broken down where it has a square root of 6. I could have done 4 and 3, but in this case I see a 6 as a factor of square root of 12. And now I notice when I have the square root of 6 and square root of 6, that number becomes 6. I'll take my first 6, bring it down, my square root of 2, bring it down, and I'll get 36 square root of 2. Other ways to do these, just what's more comfortable with. And one more. Suppose I have 8 square root of 12 over 3. Well, 8/3 can't be simplified, so I'm going to take my numerator, square root of 12. 4 times 3 is 12, so square root of 4 times square root of 3 is square root of 12. 3 in the bottom. Bring down. 8 in the numerator, can't touch that. Square root of 4 is 2. Square root of 3 stays square root of 3. 3 is in the bottom. Be careful not to cancel 3 and radical 3. One's a radical and one's not a radical. Can't touch those. So 8 times 2 is 16. 6 radical 3 over 3. I recommend you write some of these problems down, work them out, pause the video, and see if you get the same answers I have. There are other ways to simplify this. You just need practice. You also need to be able to know your multiplications. So the perfect squares beyond 10, you need to know these. 11 squared is 121. So of course that means the square root of 121 is 11 perfect square. 12 squared is 144. That means the square root of 144, of course, equals 12. 13 squared is 169. So the square root of 169 is 13. 14 squared is 196. The square root of 196, therefore, is 14. 15 squared is 225. Therefore, the square root of 225 is 15. If you know up through the perfect squares up through 15 squared for 225, and those below, that should be good.